Okay, I think it's 6:40, so we can start now. So, good evening, everyone, and welcome to the workshop on Introduction to API Development. My name is Jay, and this is NTU OSS TGIFHacks number 131. A bit about me, I'm a final year computer science student. Last year, I used to be the vice chair of Hack OSS in NTU OSS. And I have some experience on working in backend applications, particularly building APIs, testing them, and deploying them on CI/CD pipelines, and so on and so forth. So in this workshop, we are going to be looking at the basics of API development, and this is going to be a two-part workshop. So the first part, which is this one, is going to focus on the fundamentals of APIs as well as programming exercises. In the second part, we are going to take a look at security, deployment, testing, and some other strategies, and then some of the advanced techniques that we have for APIs. Okay. So here is a quick agenda for today. Firstly, we will have the introduction. Then we will move on to the different type of API examples, just to give you some motivation as to why APIs are important and why you should care about them, and also how popular they are when it comes to building, web applications or any application for that reason. Then we'll move on to the types of APIs. So there are several types of APIs: web-based, framework APIs, operating system APIs. But we in this workshop are going to focus mostly on the web API structure. So specifically what kind of protocols we have when it comes to web APIs, such as REST, GraphQL, and many more. Once we have a brief idea of the type of APIs as well as a specific protocol that we're going to use, then we will move on to REST and RESTful, which is very important for this workshop. So these two are some very important concepts that we need to learn in order to understand and build RESTful APIs, which will be the focus of this workshop. So till here, it's mostly theory. Once we understand the basics of it, we will move on to the programming exercise, which is going to be really fun. So we are going to build a very small API, but then with that example, you will understand how do we actually get started with building APIs and what do they actually do. While programming, we will hop on and off on these two things, which is request methods and status codes. This is something which you will understand better once you start coding the APIs themselves. So this is something which is really important as well to understand. And then we will look a bit more about the parameters of the APIs and what is path, what is endpoint, what is a query parameter. So a bit more depth about the API endpoints. And then finally, we will close off with the final remarks and a quick bit of preview about the workshop that we will have next Friday, which will be a bit more advanced and which will be about the topics that I just talked about. So all in all, the workshop should take around 1.5 hours, give or take 15 minutes here and there. We'll try to finish the theory part as soon as possible so that we can spend more time in the programming exercise. And then with the programming exercise, we can surely relate to both all the theories that we have learned previously. So for this workshop, if you have any sort of questions, queries, doubts, or anything at all, you can go to this website or you can scan the QR code as well. You can enter this passcode NTU OSS API and you can post your questions there. I have a tab of this website open on my phone. So I can just take a look, any questions that you submit or any query or anything that you have in mind. I'll be really happy to answer that. If you'd like, you can also submit a question on the Zoom chat, or you can unmute yourself and ask a question. Sometimes I do miss the Zoom chat because it's in a separate tab. So I prefer that you submit your questions here, but Zoom is also perfectly okay. Also, if you have any questions after the workshop, you can email me. I'll be really happy to answer any questions as well. So at the end of the workshop, I'll just put down my email in the chat. So if you have any queries later, you can just drop me an email. That also works. Okay, so let's just begin with the workshop now. So API stand for Application Programming Interface, and we really need to understand what the word interface means before even doing anything. So to give you a brief idea, right, interface is any device or any kind of program that enables a user to communicate with a computer. So it's basically sort of a place where you communicate with the computer or the computer communicates with you or vice versa. So interface is basically uh, a sort of an exchange point where we send and receive messages or try to communicate with the other party. So just to give you a simple example, right, let's talk about user interfaces. So in user interfaces, what happens is, you have, suppose you have a phone, it has a button. So suppose you're listening to music and it has a play button. And so what really happens when you push that button? So this is the user interface, which is the phone. Once you push that button, a request goes to the phone operating system, and the request says, okay, we need to play the music, whatever track is on right now, we need to play that music. So whenever you push the button, a request goes to the operating system that, okay, we need to play that music. And the operating system returns the request by playing whatever music you're trying to listen. So this comprises of user interface where you have a bunch of buttons, you have a bunch of things on a front end device basically, and then you try to communicate with the underlying machine based on the controls that you have. So this is known as a user interface. So what we are doing is you are a user and you are trying to communicate with the machine. Now, APIs are similar, but the only difference is instead of a phone, right? Instead of a user, this is also a machine. So interfaces are basically machines trying to communicate with other machines. So I think that's a very simple definition we can put for that. And in user and APIs, there are basically two parties. Firstly, we have the consumers and then we have the providers. So the consumers are those who request for information and the providers are those who actually give the information back. So for example, if we are the mobile phone, and let me just try to erase and make it a bit more neater. Okay. Okay, let's consider the example again. So suppose we have a phone which is communicating with the OS. So we are the consumer. We are trying to communicate with something, and the OS is the provider. So for this workshop, we will be mostly looking from the viewpoint of a provider, that how do we make an API so that we can communicate with the client. But we will take a look at the consumer side as well. So consumer and client are two words which can be used interchangeably. So just to give you a concrete example of what APIs are, let me go to a website and just show you an example of an API so that you will understand better. Okay, so hopefully you can see the browser tab on my screen. So this is a really famous website, data.gov.sg. So it basically provides a lot of government related data on their website. And if you go to the website, then they have a developer section. You can go to the developer section here, and then it shows two sections, real-time APIs and CCAN APIs. So suppose you want to know the taxi availability in real time of the government taxis that are available. So the way you can do that is by using this API called taxi availability. So again, if I try to use this API, then I am the client or I am the consumer, and this data.gov.sg, that is the provider, which is giving me the information. So all APIs, so I'll talk a bit more in depth about the different types of things we are seeing right now. But just to give you a brief idea, uh, this URL which we are seeing right now is the one which we query to get the results. And with this URL, we can get the real-time availabilities of taxis in Singapore. So, okay, let me just use the button to try it out. And I can optionally put in a date or time string. That is, I can if I want to query taxi availability for a particular date and time, I can just put that in this format and it will show me the results. But for now, I will just not put anything, so it will display me the results for taxi availability right now. So if I click on execute, um, you can see that this is the request URL which we queried, and this is the response that we got. So the response that we got is basically a bunch of coordinates which tell us the taxi availability right now. So it's a bit hard to understand the coordinates when we see it like that, but we have another option of a map here. So it will translate the result that we have here into a map. So it will basically plot the coordinates on a map. So if I click on the map here, so this is the result of the API. So this is the real-time availabilities of different taxis in Singapore. So this is one example of an API that is provided by the Singapore government, which we can use to get the real-time availabilities of taxis. And this is the API endpoint that we can have for that. So yeah, this is just one simple example of a web-based API. So let's go back to the slides. Okay. So let me give you another example so that things are a bit more clear. So this is what a typical architecture looks like. We have a web browser, which is us. And then we have an API, which is the middleman. And then we have a web server. So you can consider that this is the front end, which is the browser. And this is the backend, which is the database, and it is connected to a server and is serving some requests and so on and so forth. And this is the API, which stands as a middleman. So this stands between the backend and the front end. So what happens is, suppose in the web browser, you search for a request. So suppose you type in, say, google.com. So what happens is Google is actually stored on a web server somewhere. It's connected to a database somewhere, but that is the information that we don't need to know about. So this whole part is basically like a black box for us. We don't know what's going on here and we don't care. But when we do that, when we query google.com, a request is sent from our browser. And then the web server returns back the response, which is the web page of the Google, with the help of the browser API. So the browser API will contact the server, fetch the HTML or the JavaScript or whatever the output of the Google homepage is, and it will serve it back to us. So this is what a typical client server architecture looks like, where we are the clients and this is the server. And similarly, if we want to put it another way, this is the consumer part and this is the provider part, or this is the front end and this is the back end and this is the middleman, which is the API. So yeah, so I hope that this part is clear now. So just to reiterate, we send requests to a server with the help of an API, and the API carries back the request and sends the response back to us. So every time we visit any website, we are basically trying to query that particular server, and with that server responds us with the appropriate request. So to give you some more examples, you must have seen these kind of universal login buttons. These actually are the ones also which operate solely on the basis of APIs. So what basically happens is, when a website doesn't want to, make you fill a very long registration form or anything like that, they will give you an option. You can continue with a Google account, you can continue with a Facebook account or Apple account or anything of that sorts. So what's really happening behind the scenes is that when you click on a button, for example, say continue with google.com, then it sends an API call to the Google server. It will authenticate you. It will check that your credentials are correct or not. And then it will return back your details so that the website can register you on their database. So for example, you can click on continue with Google, and Once the authentication is done, then Google will provide back your name, your profile photo, or whatever permissions you give, and your detail will be returned back to the website so that they can register you. So if I continue with Google, then maybe my name and my photo will be fetched from Google servers and it will be returned back to the website. So this is done using APIs. And again, you can think of it as a sort of an abstraction, because we don't know how Google is authenticating us. We don't know how are they fetching our information, but we do not care about that. What we care about is that we are authenticated and then we are getting our information from Google servers. So another example can be any kind of third-party payment processing. So whenever you pay on a website, then there are several options that you can pay with, like debit, credit card. So this is like a standard one if the website implements it on its own. And then they'll also give you an option that you can pay via other methods. So for example, in some countries, even in Singapore, you'll find a lot of PayPal. If not PayPal, they will give you an option, pay via the QR code, which is pay anyone, pay la, um, or you can pay via nets. So what is happening is that the website is not implementing the Nets framework or the Pay Now framework from scratch. What they're basically doing is that whenever you click on a button like this, they call the Nets API and they will send your details and your amount to the Nets API. They will get your information once you provide it to them. And then based on that, the API will execute the transaction. The API will basically send a request to execute the transaction on your behalf, and then you will be redirected back to the homepage or the website itself. So when you pay via any kind of third party, right, then that also happens with the help of an API. And there are like many other examples. We have like travel booking websites, booking.com and all those. They don't have a database of all the hotels or everything by themselves. They are basically content aggregators which collect all the data from different websites and then show it to you. So yeah, I hope that's clear and give you enough motivation as to why APIs are so important, and they are basically present everywhere. So let's start with the types of APIs that are there. So one of the most common one is called the framework APIs. So a framework APIs is basically an interface to a software library where in which the API is describing and prescribing the expected behavior, and the library underneath the API is actually implementing that behavior. So for example, in Python, right, if you for any method that you use, for example, you write print hello world, then it's basically making a framework API call to the underlying print function, which will show the result on the console. So any method you call in a programming language can be thought of as an API, because so for example, when we call the print function in Python, right, or any language, then we don't know how the print function is working. We just know that when we call the print function, it will basically show us the result on a console, whatever we write in the print, but we don't know how that function is working. So every statement in a programming language can be thought of as a API call. So just to give you a quick example on the Java side of things. So I have this Java API specification open. We can have it for Python as well. Any language works. So I'm just trying to give you an example. So if I go to Java IO, which is input output, and then I go to let me see the print. Okay, we have the print stream one. If I go to the class print stream, then we have a print command. So we can see a lot of print commands. So if you want to print a character, then they have an API. I can click here. So it basically describes, it prints a character. So whenever we write system.out.print, it will basically print the character on the console. So this is the Java API, and we can think of every programming language as a sort of API which provides us with a lot of functions. Yeah, let's go back to the presentation. We can consider operating system applications also as an interface between the application and the operating system itself. So this can also be thought of as an API, because all the functions, all the methods which are present in an operating system, which as a user we can leverage to do things, they are also called or also thought of as a form of an API. So just to give you an example again, we have the Windows API here. So you can see that this is the Windows API index. So suppose I want to create a dialog box in Windows. So I can refer to this API and create a dialog box. So I can go to the dialog boxes right here. I can go to the dialog box functions. I can go to create a dialog box right here. So it gives me the C++ code that I need to create a dialog box. So I think they have an example also somewhere. Yeah, so we can take a look at this example. So they have this whole documentation. Okay, if you write this program, then it will create a dialog box like this. So what we are doing is we are basically calling the Windows API to create a dialog box. We don't know how the dialog box is created, but we are given a function through which we can do it. So this is an example of the Windows API. So the next one is remote APIs. So it can be thought of basically an interface which is trying to manipulate a resource which is outside of our own computer. For example, framework APIs and operating system APIs, right? We are trying to manipulate resources within our own computer only. But remote APIs, they try to manipulate resources outside our computers. So for example, we have the Java JDBC library. So that's basically an implementation of any sort of database that you want to implement in Java. You can do that using the remote APIs. And then finally, we have web APIs. And this web APIs will be something which will be our focus for this workshop. So web APIs are quite common, and all the examples that I gave previously, for example, data.gov.sg, they are basically web APIs. So you can web APIs also manipulate resources outside of their own environment, because as a client, we don't have the resources. We are manipulating, we're trying to get resources from a server. So you can think of web APIs as a subset of the remote APIs. But this is something which we will focus for this workshop. So just to give you an example again, there are many websites, say Spotify or Twitter, they have their own APIs. With those APIs, you can fetch the details that you'd like and that they provide. For example, the Twitter API, right? You can query any keyword that you want, for example, say Singapore, and then it will return you a list of tweets that contain the word Singapore using the API itself. So we don't know how Twitter is doing it, but then we are getting the results from the Twitter servers. And that is an example of a web-based API. So that is something which will be the focus for this workshop. So specifically for web-based APIs, right, there are many protocols that are being followed. So a quick review on the protocols is, firstly, we have XML RPC. So to understand this, we need to understand what exactly is RPC. So RPC stands for Remote Procedure Call. So what it does is, it's, without going into too much depth, right? It basically it can call a subroutine on another machine without knowing that it is remote. So we can basically call a subroutine on a different machine which is running somewhere else, but at the same time we don't know that it's remote or not, and we don't care. We just can do that using this protocol. So we can make the request in XML, and then we can transport the request. We can perform the data transfer using HTTP. So earlier, I think WordPress used to have XML RPC as a protocol to fetch data from other websites, but now they don't support XML RPC anymore. The next one is SOAP. SOAP is something which is an improvement of XML. So it's basically, you can say, version 2 of XML. It also encodes the data in XML, and it provides two data transfer functionalities using SMTP and HTTP. It's also, not as popular now, but it seems to be uh, it seems to be very popular, some time back. So because it was used in a lot of B2B applications to form a data contract. So for example, SAP is a company which makes enterprise software, and then in SAP they used to have a lot of SOAP APIs, which were used to basically to build APIs. So these two are the ones which are no longer actively used. They are not popular now. They used to be popular before, but now we have newer formats which are which work much better. So yeah, I have a question right now. Thanks for submitting that. So the question is asking, what are protocols? So you can consider protocols. I think you're partly correct. So protocols can be considered as a set of rules that we need to follow for the APIs to work. So it's basically like a standard that has been maintained for a particular thing. And with that particular standard, we can do things. For example, if SOAP is built around XML, then we can only use XML to perform the data transfer. If we want to use JSON as a data format, then we cannot do it using SOAP APIs. So yeah, I hope that answers the question. Okay, I think we have something in the chat as well. Yeah, can we get, yeah, you can get the, I think the recording will be uploaded next week from the YouTube channel. Thanks, Tom, for the clarification. It will be uploaded on the NTU OSS YouTube channel. Okay, so the next one is Json Rpc. So Rpc is again remote procedure call. So this is similar to XML RPC, except it uses JSON for its encoding, and the transport mechanisms which are available are quite high. So you can transport using HTTP, you can transport using sockets, or there are many other ways that you can transport it. This is not something which is fallen out of the API ecosystem. So Ethereum virtual machine is something which uses JSON RPC. So if you are interested, you can just take a look at this link. So this basically provides Ethereum APIs, which works on the JSON RPC format. So if you don't know what Ethereum is, it's basically a software platform that can be used to create decentralized applications on the Ethereum. So Ethereum is again so basically Ethereum virtual machine is where all the Ethereum accounts and smart contracts live. So the Ethereum execution engine, to be specific, is something which provides JSON RPC APIs. Okay. So now let's move on to the main APIs which we are going to focus on this workshop, which is RESTful. So this is the format which is the global standard and which is the most common and convenient method for connecting components. So a RESTful API is a type of API that follows the principles of REST. REST is something which I will detail more in the next slide, so don't worry too much about that. But REST is basically an architectural style, and RESTful APIs are APIs that follow that architectural style. And these APIs, for example, SOAP or XML RPC, right? They impose a strict standard as to what you can or cannot do. But REST APIs are very flexible. They provide a lot of data formats, And the only requirement that they have is that they should conform to the REST design principles, which we will see in the next slide. But this is something which is the global standard, and this is something which we will focus on this workshop. Just as a bonus, there is a new and upcoming standard called GraphQL. It's really exciting and something that it's really interesting as well. So it's a new format that encodes information in a custom language, and it returns a JSON response. So the difference between REST and GraphQL is, so for example, the example which I showed you earlier, right, on the data.gov.sg, the taxi availability. So you saw that we have a URL from which we queried that. And REST APIs have a lot of URLs, different URLs from which you query different kind of information. But GraphQL is a totally separate thing, which basically says, okay, we have only one URL, and this with just one URL, we are trying to query and we are trying to get all the data we want. So yeah, GraphQL can be something, can be a workshop on its own as well. It's a really interesting topic. And if you'd like to, have a workshop on GraphQL, then, let me know, let anyone in NTOSS know, and we will sure we can arrange something for you. But if you're interested, just take a look at GraphQL. I have some links at the end of the workshop. It's a really new and interesting format. But for this workshop, we will focus on the global standard, and which is something which is the most common one, which is RESTful APIs. Okay, so let's try to focus on these words REST and RESTful, because they can be a bit confusing. So just to start things off, right, REST, the full form of REST is representational state transfer. So what it basically means, it's basically a set of constraints which an API has to follow. Once it follows these constraints, it's called as a RESTful API. So if you try to read about APIs online, then REST APIs and RESTful APIs are something, these two words are commonly interchanged with each other. Some people call it REST APIs, some people call it RESTful APIs. But what they are really trying to say is that they have built an API which conforms to the REST standard. So REST is basically an architectural design or architectural set of guidelines that we need to follow. So yeah, I will just, it can be a bit confusing, but I will try to quickly run you through the 6 design principles of REST. So just so that you just have a brief understanding of what REST is. And afterwards, we will move on to the programming exercise and see an API live in action. Okay, so the first principle is uniform interface. So what that basically means is that all API requests should look the same no matter where the request comes from. And also the REST API should ensure that that every resource that we request have a unique URI. So a URI stands for Uniform Resource Identifier. So that means every resource should be identified with a unique URI. So if you don't understand it right now, that's okay. We will, when we try to code things up, then hopefully things will be a bit more clear as to what exactly uniform interface means. Okay, so the next is client server decoupling. So that really means is that the clients and server applications must be completely independent of each other. So when we are requesting, for example, google.com, then there is no relation between us and Google. The server of Google is running independently of us. It's not that we close our laptops or computers and Google also goes down. So these two are completely decoupled. Also, another note is that a server should not be able to modify things on the client side. It's not allowed. And also the client shouldn't be able to modify things on the server side. It's also not allowed. So the whole thing is that we should be able to transfer data, but then we shouldn't be able to modify things unless we do some specific kind of protocols, which we will talk about later. The next rule is stateless communication. So what that means is that the request needs to include all the information necessary for processing the request. In other words, it means that a REST API do not require any server-side sessions. And also server applications are not allowed to store any data from the client side. So what it means is basically if we want to get some data, then we need to supply all the information from in the API call itself. And once the API call is finished, we get the response from the server. Then the server will not remember anything, or there won't be any state changes to the server itself. So yeah, I hope that's clear for the statelessness. The next one is cacheability. So that means that whenever possible, resources should be cacheable on the client or the server side. So server responses also need to contain some information about whether caching is allowed or not. So really the whole goal of caching is to, increase the performance of the API. If we are requesting some kind of information again and again and again, then instead of the server processing that request again and again and again, we can cache the request so that whenever the client requests for something, then we can just instantly return it without needing to contact the server again. So yeah, this should be an option in REST APIs. The next one is layered architecture. So very quickly, layered architecture means is that the client and the server do not directly communicate with each other, and the REST APIs need to be designed so that neither the client nor the server can tell whether the application that is requesting something or which is communicating with each other, what kind of application it is. So yeah, that's a bit about layered system. So I have one question here. What does caching? Okay, so the question is about what caching means. So caching, okay, so just to give you a quick example of what caching means is it's about storing the data that you have requested earlier so that we don't need to fetch it again from a client point of view. For example, when you open google.com on your browser, right, then it takes some time to load, for example 2 seconds, 3 seconds, and when you refresh the page, then it loads very quickly. The reason for the request, the reason the second time the page loads very quickly is because it has cached the information that you requested earlier. So for example, Google knows that the Google logo will stay the same. Google knows that some of the icons will remain the same. So when you have when you type in google.com, it stores the Google logo and some of the icons to your local PC, so that whenever you visit Google the next time, it will not request for that images again to be loaded from the server. Instead, it will store it in your machine. So basically you store some part of the information to your local machine that is unlikely to be changed, so that the next time you visit the particular resource, that resource will get to you quickly. So that basically means what a cache is. So there's another question: where do we cache the data for the web application? Yeah, that's a great question. So basically, caches are stored on the local computer as well. Inside the local computer, every browser has its own cache directory in which all the caches are stored. So in fact, you can go to your web browser and you can request for your cache to be cleared. Once your cache is cleared, the browser will delete all the stored images or all the stored data that it has. So the next time you visit a website, then it will fetch all the information from the server freshly. So I hope I got that question right. Yep, that's correct. So we are basically trying to store some information from the server in our local machine. So the cache storage can be simply thought of a directory which exists inside our local machine that contains some information from the server that is something which is unlikely to be changed in the future, so that we can just directly fetch it from our local machine. Okay, I hope caching is clear, but yeah, it's a way to improve the performance by storing data offline, so that we don't need to fetch the data again and again. Some data which can be static and some data which, which is unlikely to be changed in the future. Okay. The last one is code on demand. So this is something which is optional, but it basically means that some of the APIs, instead of returning like text or JSON response slide, some of the APIs return code. So for example, Java applets or something like that, they return code, and that code should only run when requested by the user. So yeah, I think we do not need to go too much in depth about the code on demand. And this is something which is a bit out of scope for this workshop, and we won't be covering it for this part. All right, so just to give you again a brief introduction about the client server architecture is basically, we are the client. We request a particular resource, say google.com. It goes to a server. We don't know how this is working or how that's happening. And once we have the request, the web server will return us the response, and we will see the output in our web browser. So this is again an overview of the client server architecture. And the reason why we are reiterating this, it's that it's very important to understand client server architecture for building APIs. So just to give you a bit of perspective, we in this workshop are working from the perspective of a server. So we are building APIs such that whenever any client requests something from us, we can return the response back to the client. So yeah, we in this workshop are focusing from the lens of a server rather than from a lens of a client. Okay, so now let's come to the fun part, which is the programming exercise. So for this programming exercise, we are going to take the use case of NTU OSS. So the use case is really simple. NTU OSS is a CCA in NTU. And suppose we have a website and a mobile app. Let's suppose we have that. We have a website already. Let's suppose we have a mobile app as well. What we want to do is we want to register new users on the website and on the mobile app. And on the website or on the mobile app, we also want to display the list of members or the list of users that NTU OSS has. So the way we can do that is using an API. We can build an API that will basically perform the following functions, which I'll just show right now. So before that, NTU OSS has members. A member, it can be expanded to, staff, faculty, alumni, but for the sake of simplicity, let's just consider students. So NTU has member students, and we can think of three parameters. Every student has a name, every student is from a school, and they have a graduation year. We can have any parameters or anything, but just for this example, let's say these are the attributes we choose to store for NTU OSS members. Now we want an API that can add members to the NTU OSS list. And we also need to have a function which can fetch members from the list. So for example, in the website, right, we can provide a form. The form will basically ask you to enter these three details, which is your name, your school, your graduation year. Once you do that, the API will call the server and add your detail into the server. So suppose we have a database, say SQL database, anything, you can think of any database, and the website, the API will basically add your name to the NTU OSS server. And we can also fetch the members. So if we want, then we can call the API and it will return us all the names of the members which are in NTU OSS. And once we have that API, we can use it anywhere you want. We can use it on the website, we can use it on a mobile app, we can use it on, you can build anything we want. Basically, any web service, we can use the API to add members to NTOSS, and we can also use it to fetch members from the NTOSS server. So we are going to build this API, which does this very simple thing. So yeah, this is like one simple example of an API that you can think of. There are many complex examples as well, which I can show you after we are done with the programming exercise. But for now, let's focus on a very simple API that adds members, and we can also fetch the list of all the members in NTOSS. So yeah, you can scan this QR code if you like, or you can go to this link and you can download the GitHub repository, and from there we can get started. So I will just paste the link in the, I will paste the link of the GitHub repository in the Zoom chat. So if you want, you can just go to the link and, you can click the code section here. If you want, you can git clone it from here. You can just copy this link. You can open your terminal and type in git clone, and this URL, it will download the repository. You can use GitHub CLI if you want. You can just copy this link and you can just paste this link directly in your terminal if you have GitHub CLI installed. Or if that is also not a case, you can just simply click on download zip file, which will download the code as a zip. So anything works. We just need to have the code in our computers. So let me just paste the link in the Zoom chat. Okay, I hope everyone can see the link. So let's just take a quick 2-minute break. Meanwhile, in the break, you can just clone the repository and let me know if anyone has any issues. Once you clone the repository, you can open the repository in VS Code or basically any code editor you like, but I'll be using VS Code for this workshop. Yeah, so let's just wait 2 minutes for everyone so that they can clone this repository. Okay. Also, just to clarify on one earlier query that someone had regarding cache. So someone mentioned local or session storage. So let me just clarify that sessions and caching are different things. So sessions can be thought of in a form of cookies. So for example, you can log into a website and you can close your browser, and then the next day you open your browser and you visit the website again, then you're already logged in. So that happens because of cookies. So cookies are something which are used to store this kind of information, and then they can remember that you already logged in into the website. Whereas cache can be thought more in terms of data that you're trying to store, specifically static data, which is unlikely to be changed in the future. So just a bit of clarification about that. Okay, I hope everyone is able to download the repository. Is anyone having any issues? They can put it in the Zoom chat. Anywhere should be okay. Okay. Okay, it seems like everyone is good to go. All right. So if you navigate to, so this is the directory structure that we have. So we will be focusing on part 1 of this workshop. Part 2 is empty. We don't have anything. So this is only for part 1. And you can ignore all these files for now. You can just open hello world. And I'll just even remove this one. So we can just write a quick program from scratch. So before starting any coding, for this workshop, we are going to use Python as a programming language. And in Python, we are going to use a framework called Fast API. Fast API is a really good framework which helps us to build APIs really quickly. It's really nice and it has a lot of features. And you can also use Flask if you want. Flask is also something which is very popular. But for the sake of simplicity for this workshop, we are going to stick with Fast API. But the programming is pretty much the same in both of them. So if you want to try later in Flask, that is also okay. All right, so let's just start. Let's just make a very simple, very simple and easy API so that we can just see what's going on. So firstly, we will import Flask, we will import Fast API. So we just imported Fast API. Then we will create an instance of Fast API. So we will call the instance as app. And then I'm going to write a decorator. So if you don't know what a decorator is, don't worry about it. Let's just try to build something, and then we'll go through all the lines line by line. So we will call the instance and we will say dot get. So get is a HTTP method. We'll get to the methods later. And then we will specify an endpoint. So we will say app.get and an empty endpoint. So instead of the empty endpoint, we can have, in the case of NTOSS, right? If you want to build an API, we can have like, we want to visit this members endpoint, but let's just say it's an empty endpoint. Once we have that, we will define a function. We can name it anything. We will name it root for now. And we will simply return a message, hello world. So this is basically a JSON message we're trying to return from the API that simply says hello world. And that's pretty much it. So what this code should do is that when you start the API, you should go to the home page, which is like just a /. And once you are at the home page, then you should see this message, hello world. So you should see this response from the API. Now, in complex ways, this can be a lot of things. For example, this can be, we are doing some processing, we're connecting to a database, we're returning some specific things. But just to begin with, we just have a message called hello world. Yep, that's correct. We will need to install the dependencies. I will come to it in just a minute. Thanks for pointing it out. Yeah, we'll just come to it. Yeah, so we have this basic code. All right, so now what we need to do is we need to install the dependencies. And after installing the dependencies, we need to run the code. So let me just try to show you how to install the dependencies. Okay, if you go to part 1, okay, if you are on Mac, then you need to follow these 3 commands. If you're on Windows, then you need to follow these 3 commands. What we are basically doing is we are creating a virtual environment. Once we have that virtual environment, we are activating the environment, and then we are installing all the packages that we need for the API to run. So let me just go back and show you. So you can, if you have a VS Code open, you can go to terminal and click on new terminal. Once you have that, you have this terminal, right? Let me just clear it. Okay, so I'm already in my virtual environment, but I'm already here. But for you to do that, you need to create a virtual environment using the 3 lines which are given below. So you can go back to your root directory wherever you cloned your code. So let me just deactivate this one. Okay, so it should look something like this. You have the repository name. You have cloned the repository here. You first need to create the virtual environment, and then once you do that, you can follow this command to create the virtual environment. So this is basically the name of the environment, env. I have named it venv, but anything is okay. You can name your environment anything you like. Once you have that, you will see a folder created right here with your environment name. For example, I have venv, but you can name it anything you like. Then you just go source your environment name, bin activate. So it will activate a virtual environment, and now you will see the environment name behind your computer name. So these instructions are for Mac OS or Linux, but yeah, if you're on Windows, you can follow the alternate instructions, and that will create a virtual environment for you. Once you have that virtual environment activated, then you can go to part 1, cd part 1, and you can write, so basically there is a requirements.txt file inside part 1. So this basically lists down all the packages that you need to install in order for the API to work. So you can just type pip install um, requirements.txt, and it will install all the dependencies for you. So you can just type in this command, and it should install all the dependencies for you. So I will just wait a minute again so that you can follow these 3 commands, create a virtual environment, activate it, and then install all the requirements. If you have any issues creating the environment, activating it, anything like that, just let me know. It should be pretty quick to go. Okay. Okay. I have one message regarding a package. Let me just see. Just a minute. Okay, so I think for Windows, you have a message for UV loop, which is not supported. Let me just see. Okay, this one. Okay, let me just one minute. Let me just see. what the package really does. Okay, I'm not too sure if it's important for this one. For Mac, I think it is able to install itself, but for Windows, I'm not sure why it's not implementing. Okay, but okay, one thing we can do is you can remove this line and try to install the requirements.txt again. If we have any error later, then we'll figure it out. But I don't think it's very important to install this package at this moment. Okay, I hope everyone has installed. Okay, so now we will try to run the API itself. Okay. So to run the API, so let me just change. Okay, hello world. So you need to write two commands. You need to write uvcon, UVICORN, then the name of the application. For example, we have hello world here, colon app, which is the name of the instance, and then we can have the reload command as well to make sure the application reloads whenever we do any changes. So yeah, you can use this command. And let me just also paste it in the Zoom chat in case you're not able to see it properly. Okay. Once you have that, it will say the application is running on this URL. So I think this URL should be the same for everyone. Yeah, you can click on this URL, control click, and then it will open your browser. So let me just open my browser. Okay, it's 127.0.0.1 8000. So when we go to the URL, it gives me the message hello world. So this is basically, we are at the root of the API, and at the root we are getting this message hello world. So just to illustrate you how endpoints work, right? So for example, instead of this, I would have typed / hello world. So now this is the new endpoint that I have. So if I go to this homepage, it will say not found because we don't have anything. But if I say / hello world and then click again, then this is the new endpoint, which is the RIP extension, and then the endpoint name, which is hello world. So yeah, so this is just a very basic example of an API. We queried a server and we got a response, which is hello world. Now there are basically three ways you can get this response. Firstly, you can get it in the browser itself. Secondly, Fast API automatically generates documentation for you. So you can go to the URL, which is 127.0.0.1 colon 8000, which is the port number, and then you can click and write / docs. Once you write docs, you can see that there is a GUI which is automatically created by the Fast API framework, and you can see a get call. So we'll get to what get is later. So you can just see that there's a get call, and you can click on try it out. You can just execute it. There are no parameters, and then you get a response, hello world. So now you can use this API call anywhere you want in a program, in JavaScript, in Python, in any kind of program that you are writing to get this particular message, hello world. So the final way you can get this response is using a very famous tool known as Postman. So I hope you have Postman installed. If not, that's okay. You don't need to have Postman for this workshop. It's something which is good to have. So Postman is another API testing tool. So you can key in the URL which you have, and then you can key in the get request, which we are trying to do right now, and you can click on send. Once you have that, you will okay, yeah. So here we have the response, which is not found. Now if I go to /hello world and then we send again, then we get the response from the server, hello world. And suppose you want to use this API in your Python program, for example. So you can click on, let me see, I forgot.
Yeah, sorry, Jay. Does someone send a message in the Zoom chat? She says she had a problem trying to type in one of the commands.
Okay. Oh, okay, I see now. Sorry about that. I didn't see the chat. Let me just show you how to get the API programmatically. Then I'll just get to the chat. So yeah, you can click on this code function, and suppose you're building a Python application, right? You can click on Python here, and it will show you the code. And then how do you what is the code for this API call? So I think this is the one for the previous one. I was testing something, so we don't need anything. We'll send this. Yep. So it is showing you this code. If you copy and paste this code into your Python program, you will get the response from this API. It shows the URL, it will get the request, and it will show the response. So if you're working in, for example, Node.js, say Node.js native, then you need to basically use this code to call the API, and then with the API you can get the response back. So yeah, there are a lot of options here. So Postman is really helpful for if you want to test APIs, if you want to incorporate APIs into your own program. So there's something which you can use. Okay, so let me get back to the chat and see what the error is. Okay, I think, okay, so basically not able to activate the virtual environment, is it? Okay. Apart from, is everyone else able to run the code till here and able to see the results on their machines? Let me just meanwhile just check this error. Yeah, I cannot. Okay, so for the first one, right, the error, you're not able to activate the virtual environment. I think you might be using the command prompt. Instead, if you're on a Windows platform, you can use Windows PowerShell. In the PowerShell, you should be able to activate your virtual environment. And while you are doing that, just try to make sure that you are in the same directory as your virtual environment. So for example, if your virtual environment is here, which is outside of part one, then you need to go outside part one, which is in the main directory here, and then write the command to activate the virtual environment. So for example, in Mac, I have venv bin activate. In Windows, you should have a folder called scripts, and then inside scripts, you should have a activate, which should activate the virtual environment. There is another error. I can't find the scripts file in my virtual environment. Okay, that's strange. You should be able to see a scripts. Let me just see. You're not able to find the scripts folder. Okay, strange. Okay, you can try these commands for Windows. For everyone who's using Windows, if you're having issues, you can try these 3 commands, and then hopefully it should work. Just make sure when you're executing the last line, you should be in the same directory as the one in which the virtual environment is created. So if you execute these 3 commands simultaneously, then it should be hopefully okay. Okay, where are we? All right, so in the interest of time, I think I will just move on for the rest of the workshop. But yeah, please feel free to put it in the chat if you have any technical errors. If not, you can just go ahead with the workshop, or you can just email me also later if you have any issues. But yeah, I think the best we can do is resolve it right now, so you can just follow the workshop all along. All right, so in this basic hello world app, right, there are a bunch of things which you need to understand. Firstly, we need to understand what a get call is, for in fact what this decorator basically means. So let me just go back to the slides and show you what the different kind of HTTP headers are. Okay. So whenever we make a HTTP request, right, we need to specify what kind of request it is. For example, just now we mentioned we need to make a get call. So we put app.get. We can also put app.post, app.put, app.delete, or there are many other headers, request methods that are available. So the request headers basically, oops. Okay. So the request headers basically, they are a way to indicate what sort of action we want to perform. Okay, perfect. It works. It works. Okay. All right, perfect. All right, so to follow HTTP request, it's basically we are trying to specify what kind of action do we want to perform. So right now, if you recall, we wanted to get a message, hello world. So what we did, we put a get request. Get means we are trying to request for something. Suppose we want to get a tweet from the Twitter API. When we try to get a tweet from the Twitter API, then we will perform a get request. Similarly, we have a post request. Suppose we have the NTU OSS API and we want to add a new member to the database. When we want to add a new member, we will need to send some information to the API call. So right now we just got the response, but we didn't send anything. But if you want to create a new member, then we need to send some information to the API. To do that, we will perform a app.post. So post will basically submit something to the resource. If you want to submit an image, suppose you're working with AWS and you're working on a computer vision API that returns you, what kind of object there is in the image. So you submit the image using the API, and the API will perform some action and will return back to the response. To do that, we need to do the post request. Then we have the put request. So put is something when you want to edit a resource. For example, I am already registered in NTU OSS, and suppose my major changes or any of my particular changes, then we can use the put response request to basically edit an existing resource. And then we have a delete. So a pretty self-explanatory. For delete, we just We just want to remove, for example, if I'm registered in NTOSS and they want to remove me as a member, then they will use a delete request to remove something. These four are quite common. You will see me use these in this workshop, but there are many others as well, head, trace, patch, many other options. But yeah, we will be using these for this workshop. So I hope the request method is clear. One last thing I want as a theory part I want to show you is that, when we send the request, we got a status which says 200 okay. If you recall, when we were using the data.gov APIs, we got a response code 200 again, which says okay. When we use the fast API documentation platform, we get the response, we got a code 200, which is okay. So what does this code really mean? So yeah, let me just go back to quickly show you the codes. Okay, so these are some common codes that you will get while you are building APIs. So you can get 100 1xx. So basically that means any code from 100 to 199 is a 1xx code, which can be information code. For example, the service is running or any kind of information the server wants to give it to you. Then we have the 2xs code, which is success. So it can be any number from 200 to 299. So for example, right now we just got 200, which means okay, everything's fine, everything works. Then we have some other code as well, such as redirection, client error, server error, and these are some of the common codes that you'll find while working with APIs. So for example, suppose you make an API call, but you do something wrong. You don't specify some things which are required in the API call. So it will give you a 400 error. That means there's something wrong on your end. Similarly, if you get a 500 error, that means you perform the API call correctly, but then something's wrong with the server itself. So it's not your fault, but something's wrong on the other side. That's why there's a server error. So yeah, here's a quick introduction to the API status codes. All right, so let's go back to the programming exercise. We will try to finish the programming exercise in 15 or 20 minutes. I hope that's okay. We are going a bit over time, but I think yeah, for this part we will not try to write the code ourselves. Instead, just understand the code and then test the API itself. So yeah, okay, so you can go to part 1 and open this code, and there are basically 3 files. So with these 3 files, we are able to create the NTU OSS API. So what we are trying to do is we are trying to create a database. So we are using SQLite, which is an inbuilt in-memory Python database. In this database, we will store the NTU OSS member list. And with the API, we will manipulate the database in the ways we want. So we will add a member or delete a member and so on and so forth. So the first file you can visit is database.py. So this file is really simple. What we are trying to do is we are simply creating a SQLite database, and then we are initializing a session on it, and then we are constructing a base class. So this is something which you don't need to understand at this point. Just think of it as database configuration. So we can just think of it as database config. So it's as simple as that. So this is basically configuring our database. The next file you should visit is schema.py. So we are in this file, we are basically trying to represent the database table that we have in terms of Python. So what we are doing is we're creating a class called DB member, which is database member. So this can be anything. This can be NTOSS member. The name can be anything. And what all it means it is inheriting the base class which we declared earlier. Here we specify a table name called members. Inside the members, we have 4 fields as we discussed. We have ID, which is the primary key of the table. We have the name, we have the school and the graduation year. So all these are strings. Graduation year is an integer, but the rest are all strings. So you can just think of this as we are creating a table inside the database that we just mentioned. So, you don't need to do that for this workshop. You can simply have a list. You can simply have a list of members where you just keep on adding students and things like that. But for this one, we are using a light database. But I mean, you don't need to understand all of it, but just try to understand that this is a table that we are creating with the help of a Python database. All right. So the last file that you need to visit is main.py. So yeah, so let's try to understand what's going on here. So firstly, we create instance of Fast API. We name it app. Then we create a database dependency. So yeah, so basically what we are trying to do here is we are creating a session on the database so that we can connect to the database for every request. So whenever someone queries our API, we need to connect to the database, get some information or store some information or things like that. So for that one, we are trying to create a database dependency here. Okay, so this is again not too important for the simplicity of this workshop. It's something which is you can consider as sort of a starter code that we have. All right, so this is something which is a bit important. So there is a library called Pydantic. It is a Python library which is used to perform data validation and create data objects in Python, and it is integrated into the Fast API architecture. So what we are trying to do is we are creating a class that contains three things: the name, the school, and the graduation year. So what is the purpose of this class is that we are basically creating a member object, and we want this member object to be passed on to the API. So suppose we want to fetch a record or we want to post a record, then we will use this data structure as a reference. And with this reference, we will perform all the functions. So we just specify the name should be a string, the school should be a string, and the graduation year should be an integer. So again, not very important, but again, just to understand that this is a data structure that we are creating that will contain the student data. So I call it member, you can call it student, you can call it NTU OSS members, anything that you like. All right, so these are the functions which are used to manipulate the database. I will get to them later. Let's just take a look at the API first. Okay, so all right, let's just take a look at one function which is called create NTOSS member. So here I use app.post. The reason I use app.post is because I want to post a member into the NTOSS database. So when I use the word post, that means I will be sending some information to the API, and with the information that will be used to add a member to the database. So I will specify an endpoint, which is members. So if I don't specify an endpoint, then it will just go to the root URL, but I want to segregate the resource allocation. So I will use an endpoint called members. And then I will say that the API will return a response, and the response should be of type member. So again, we described the member here. So the response should contain the name, school, and the graduation year. Now we will create a function as we did before. The function will take in two things: the member object, which is basically I will send in my name, my school, my graduation year, and that will be in a form of a member object. And then I will also pass in the database. So this is something again which we don't need to go in depth, but just we can understand it in the form of we are injecting a dependency that we want the database as well, because we are inserting information into the database. So yeah, so I have this helper function called create member, in which I will I will pass in the member and the database. and return the same object to the user. So let's take a look at create member. So create member is a helper function. What it is basically doing is that we pass in the member object. The member object contains, remember, the member object contains my name, my graduation year, and my school. Once we have that member object, then we basically add it to the database and we refresh the database. So again, this is something which we do not need to understand at this point. We could have had a list of objects just like here, like a list of objects, and we just add it to the list, like list.append. But for now we're using a database, so we will use these three functions. So whenever, just to reiterate, whenever I do a post call on this endpoint with this data, I will insert a member into the OSS database, and I will also get a response from the API that will contain the same member object. So just to illustrate, let me just try to run this code. So you can go back to your terminal. You can type in the same command, uvcon. You can now change the name of the app to main, and then you can say app reload. So you can just do that. I will just put the same command in the Zoom chat in case anyone is running the same command on their machine. Okay, I hope everyone is able to run the code on their machines. So again, it will show me a URL. It should be the same one as the last one. So I'll just go to my browser here quickly. Okay, I will type in the URL and then I will type in /docs. So again, /docs will lead me to this page from where it is easy for me to test the API. I can use Postman as well, but for now I will use the URL /docs. So it should be 127.0.0.1:8000/docs. So now it shows me a post request, a method post requests with the endpoint members. So it says a request body is required with the following parameters. So I need to send this data. And once I send this data, it will create a member in the database for me. So I can click on try it out. So it requires me to have a request body. So here I will type my name. From the CSC, I'm graduating this year. So this is the request body. So this is the request, this is the payload, or this is the data that I'm sending to the API. I click on execute. Once I click on execute, I get a status code of 200. That means everything's okay. And then I get a response body, which is the same data that I submitted. Here I can have it as simply as status, which says data successfully submitted. I can have that as well, but just for now, I'm just having the same data that I submitted back to me so that it confirms that I submitted the data correctly. So you can say the request URL is the IP where we have deployed the application /members. So /members is the endpoint that we're trying to use. Again, we can use Postman as well. We can say members, which is the endpoint. We can do a post request. Inside the body, we can have a JSON type body. And then here we can specify the 3 fields. For example, we can have name Tom, we can have the school, C, we can have the graduation year, 2024. And then we can send the request. we get a status of 200. That means everything's okay. We submitted the request to the database and we get the response back. Again, if you want to implement this in code, if you have your own application, you can click on the code side here. You can select any language you want, for example, Python. It will show you, okay, this is the payload. This is the headers you want. You just copy and paste this code and it will send the API call using Python. All right. So this was to create a member. Now we want to fetch the members as well. So for this workshop, we will focus on this function. It's pretty straightforward as well. So again, we are using the same endpoint. So we can use the same endpoint again and again. The only thing is the decorator should be different. For example, now we want to get all the members from the API. So I will use app.get instead of app.post. But all the remaining details should remain the same. So once we have that, we will specify what kind of response we want. So we want to get all the members. So for that reason, we will type in, we don't want a member, instead we want a list of members. So again, we will have the function code here, which is basically we inject the database. And this is a sort by, I think you can ignore this for now, but this basically sorts our information into alphabetical order. And then I just return a helper function in which I pass the database. So again, in the get function, I need the details of all the members. So I do not need the user to tell me what member it is. I will just query the database for all the values. So again, this get members is a helper function right here that just returns all the members. This is the get members function, and it will return me db.query and will return me all the members. So this is a function call for the SQL API, SQL Alchemy API to be precise. You can Google it if you want, but it basically contains some basic things which we can use to query the database. So again, the implementation of this get member is not important. What is important is that we are getting all the members using this function. Again, if you put a sort by parameter, then it will sort by using a specific field which you want. So just to reiterate, we have a get function that will work on this endpoint and it will return me a list of all members. So we can go back to, for example, the browser. So just remember, I submitted 2 responses. Firstly, I created a member myself, and then I created a member called Tom. So if I go to the get one and I click on try it out, so here I should get the list of 2 members in NTOSS. So if I click on execute right here, see, we have a code of 200, which is successful response. And we got the response body, which contains 2 members, myself and Tom. Now again, this is the auto documentation that we have. We can try it in the Postman app itself. We can go to the URLs, which is the same one, which is /members. And then we can have a get call. So in the get call, we do not need to have any body. We are just trying to get the data. We click on send. Here we have the response. So this is, so now we can use this API in any application you want to basically create members and also fetch members from the database. So this API right now is running locally, but we can deploy this API into any server. So we will have, say, xyzdomain.com/members. And then from that, we can get the responses and also create members. So yeah, I think this might feel a bit rushed, but after the workshop, you can have a look at the code. It's actually really simple. We just have 3 helper functions that help us to communicate with the API. And then with these helper functions, we create 3 methods, get and post. And in these methods, we just return and create new members. Yeah, so that's pretty much it for the programming part for this workshop. I will just take a pause here for any questions or any queries that you might have for this one. Okay, so we have one question. So the question is, do we need to use SQL Alchemy with Fast API? No, we can use anything we want. SQL Alchemy, I have used SQL Alchemy because it is quite straightforward to implement for this workshop. You can use raw SQL, you can use MongoDB, you can use Postgres or any database which you like. There is support for every database in Python. So if you want to use any other kind of database, that is also perfect. So yeah, SQL Alchemy is quite straightforward to implement, but yeah, any database works. All right, so just to take a few more minutes for this workshop, let me just try to all right, so we have just one little thing that I like to reiterate, I like to say here is the path and the query parameters. So suppose we have deployed the API to ntoss.com and we have this endpoint members. Now, there are two ways we can query a member. Firstly, we can have it /ID, or we can have it as question mark, and then we can specify a single parameter or multiple parameters. So I think you'll get a more better glimpse of it in the next workshop. But just to give you a brief idea, if we use this kind of annotation, that then we are trying to basically identify any specific resource. For example, if I say /members/j, if I have a function like that, then I'm trying to identify any specific resource. If I have a function such as question mark school is equal to SCSC, then I'm trying to filter a specific resource. So yeah, it seems a bit out of context here, but we will get into more depth into path and query parameters in the next workshop. So hopefully that will be more clear the next time. So so just to sum it up, APIs, they form the backbone of every application that you've probably used. We have the front end, we have the back end, and the API is basically a sort of a middleman that sort of communicates between one entity to another. So you can think of them as messengers, and these messengers carry some data back to the server and return you some data from the server. And APIs can be anything. So they can be as simply as framework APIs, or they can be something very complex. So just for example, I gave an example earlier. Say you are using an object detection function from Amazon Web Services or any cloud service. So they will provide you with an API. They will say that use this URL. In this URL, just send us your image. We will process it and we will return you the output. For example, the output should be what kind of object is present in the image. So we will have to build an API. So Amazon built an API that will send your image to their servers, get the response back from the servers, and send you the response back. So that is one example of a very complex API. So again, the whole point of APIs is we do not need to know how the server is processing these things. What we need to know is basically the request is being processed and we are getting some response back. So if you want to know more about APIs, or if you want to learn more, then I highly recommend learning Spring Boot. It is something which is used in almost all enterprise software development. It is an API library which is based on Java, and it's available in Kotlin as well. So if you try to work for any organization that is working on enterprise software, then most likely they will be using Spring Boot as their API framework. Or you can use Flask or Fast API. So Fast API is something which we use right now. It's available in Python. If you're working somewhere if you're working with building machine learning models or anything that requires a Python environment, then these two are very common frameworks and libraries for Python for building APIs. So yeah, that is pretty much it for this workshop. For the part 2, which will be held next Friday at the same time, 6:30 to 8:30, we will be talking about security. So right now we can, so for example, right now anyone can deploy the API, and uh, anyone can use the endpoint which we created, but we also need to secure the endpoint. For example, if Amazon has an endpoint for this API, then I cannot just simply use that endpoint to get something. I will need to pay Amazon. And when I pay Amazon, they'll provide me with a username and password, for example, and I can use that username and password to unlock the API basically, and then use it. So we look at security and authentication. We will look at API standards. We will also deploy the API to Heroku, and we will also look at CI/CD pipeline and testing. So one question I have in the chat is that is Django recommended for building APIs? Well, I think Django is also a really good platform in Python for building APIs. I feel personally that Django can get a bit more complex. So if you are starting to build APIs, then Flask or Fast API is pretty easy to learn. Once you have a good grasp of these frameworks, then Django is something you can go for. But yeah, if you feel like working with Django, that's also perfectly okay. It's also an amazing framework for building APIs or backend in general. So I hope that answers the question. So yeah, so in the part 2 of the workshop, we will be looking at these things plus a lot more. So if you understood this workshop, then the next workshop will be even more interesting. If you have any queries for this one, just let me know in the comments, in the Pigeonhole channel, or in my email ID. Anything works. Yeah, so I have a few links as well for this workshop. If you want to learn more, if you want to learn more about Spring Boot or Spring Boot in Kotlin or Java, as well as Fast API or even GraphQL, you can have a look at these. So this presentation is uploaded on the GitHub repository itself, so you can follow the links there. And yeah, that is pretty much about it. I will just key in my email ID in the chat in case you want to send me any questions later. And thank you so much for attending this workshop. Thank you so much for your time. And I hope I see everyone next week at the same time. Thank you. And yeah, if you have any questions, I'll be in the chat. I'll be in the Zoom call for the next 5 to 10 minutes. So please feel free to post any questions in the Zoom chat or in the Pigeonhole channel if you have any.